finally, we have to deal with absolute values and greater than inequalities. I mentioned previously that the less than and greater than have to be dealt with in different ways, and so we'll deal with the greater than in this video. I'll take a basic example, just like we started off with before. Something like the absolute value of x is greater than 8, okay? And so basically what this inequality is asking us to find are values of x whose absolute value is greater than 8, or whose distance from 0 is greater than 8. And so you can imagine there are things that are farther away from 0 than 8, or farther away from 0 than negative 8. So going in both the positive and negative direction. On the number line, I could represent that very simply by noting the negative 8 and the positive 8. You put 0 in between them somewhere. And so all the numbers whose absolute value is greater than 8 would be all the numbers out here on the left of negative 8 and all the numbers out here to the right of 8. Okay, so it's two different sets or two different intervals. And neither one of them in this case includes the endpoint because there's no equal sign in this inequality. So we're going to have parentheses there. Now, remember when we have two different intervals and we're trying to include points that are in either one of them, we're going to use a union to represent that solution or that total set. So I'm going to use the interval from negative infinity to negative 8 union with the interval from 8 to infinity, okay? And so this shows that this is the union of two different intervals is a final interval with, all the points from one or the other. If I wanted to represent this in set form, I would have to represent it using two different inequalities. It'd be all the values x such that x is less than negative 8 or x is greater than 8. Remember, with a union, we use the word or, and we'd have to have both of these inequalities listed separately. Remember, the and statement, we can get them in a three-part inequality. If we have an or statement, we cannot. Okay, so we have to keep them separate. Okay, because we're not solving, we're not finding values that solve them at the same time. Okay, the two different sets. Okay, so that's kind of a basic one. Again, whatever's in the absolute value must be farther from 0 than 8. So it has to be everything less than negative 8 and everything greater than 8. Okay, so there's really two different inequalities to deal with here. It's all the x values that are less than negative 8, and all the x values that are greater than 8. Well, if you think about those two inequalities together, you end up with one of them just being the x greater than 8, which is what you would have if you didn't have the absolute value on there. The other one is the opposite of both. You have the inequality symbol changing and the negative changing, right? So you have both things switching around. And so you end up with x is less than negative 8, all right? So there's two things. One is whatever's in the absolute value is greater than the number, and whatever's in the absolute value is less than the negative. Okay, so let's try another example. But let's make it a little bit more complicated where there's more stuff in the absolute value. Something like, let's use a different color. Something like the absolute value of 5 minus 2x is greater than, let's go with 13, okay? So here, again, we're looking for stuff in the absolute value whose distance from 0 is greater than 13. Simply put, on a number line, the 5 minus 2x, the stuff in the absolute value, has to be either out here less than negative 13, so that's where our 5 minus 2x has to be, or they could be out here to the right, greater than 13. All right, so the 5 minus 2x is out in those two regions. Of course, 0 in here somewhere. And so all the numbers out in those two regions are going to be farther from 0 than 13 units. Okay, and that's what this inequality is essentially expressing. So I need to solve both of those because I don't really care where 5 minus 2x is. I want to know where x is. And so I've got to solve each of those inequalities by themselves. The first one on the left must switch both the inequality and the sign on the right. But the stuff in the absolute value is it just comes down and stays what it is. So it's 5 minus 2x must be less than negative 13. 5 minus 2x, stuff in the absolute value, less than, change the inequality, negative 13, change the sign. Or it could be greater than 13. So it's 5 minus 2x is greater than 13. So again, two intervals, two inequalities to solve will result in two intervals. The one on the left here, to solve for x, I need to subtract the 5 from both sides. Negative 2x is less than negative 18. Divide both sides by negative 2. And I get x is greater than 9. Notice I have to switch the inequality from less than to greater than. Okay, so x is greater than 9 is one of the intervals I'm looking for. The other one, again, subtract the 5. Negative 2x is greater than, what's that going to be, 8. And then divide by negative 2 again. X, now that inequality will change again because we're dividing by negative. It'll be x is less than negative 4. And so that gives me two intervals. The first one, x is greater than 9. The second one, x is less than negative 4. If I were to plot those on a number line, just so you can see, maybe I'll keep drawing these with a slope going down here. Maybe I overcompensated. I think that's pretty horizontal. Let's put the negative 4 in there on the left, the 9 in there on the right. Now this is the final solution number line. The original number line I drew up here is just a number line that I used to help me to break down or break apart the absolute value into two inequalities I can solve. This is not the solution number line. The solution number line is down here at the end when I've got x's by themselves. I get x greater than 9, so that's going to be everything out to the right. And I get x is less than negative 4, so that's everything to the left of negative 4. And when I combine those into a single set, I can again either use the interval form, which would be negative infinity to negative 4, union 9 to infinity, or I could put them in a solution set, x such that x is greater than 9, or x is less than negative 4. Okay, so again, a couple different ways to represent that solution. Again, the main thing is you want to take whatever's in the absolute value, make it greater than 13, that's one of the options, or less than negative 13, that's the other option. So you need to be able to do both and then solve, and the final solution will be the union of those two sets. Okay. Now, finally, there are some, well, there's two other things I wanted to mention. One of them is, if I have other stuff outside of the absolute value, you've got to isolate the absolute value first. For instance, if I had something like, 5 times the absolute value of 8x plus 3 plus 11 is greater than or equal to, I don't know, 19 or something like that. I'm just throwing some things out here. Then I've got to isolate the absolute value before I can do anything else. There's a temptation to try to move things in the absolute value. Don't do that. Absolute values do not work the same as parentheses do, and so you can't combine things in and out of the absolute value. Instead, what you have to do is solve for the absolute value. So you got to get rid of the 11, get rid of the 5, and then you can break it apart. I'll show you this real quickly on this example. just so you can kind of see how it breaks down, we start by subtracting the 11 from both sides. I've got to get it away from the absolute value. So this becomes 5 times the absolute value x, 8x plus 3, greater than or equal to, what's that, 8? Then I divide out the 5, right? So just like I would be solving for a variable here, I'm solving for the absolute value, trying to get it by itself. So I divide the 5 on both sides, and I'm left with just the absolute value on the left, greater than or equal to, well, 8/5. Well, 8/5 is 1.6. I could write it either way. I'm going to go ahead and do the 1.6 because I'm trying to do this quickly. Yeah, that should work. Now I have it in the form of an absolute value greater than a number, just like we had before. And so I'm going to split it up 2 ways. I'm not going to show the number line, but essentially you're looking for the 2 ends. The first one is that the stuff in the absolute value must become less than or equal to negative 1.6. Remember, you change the inequality symbol and the sign on the right. And then the other inequality, get rid of some of this, is, right down here, is going to be the stuff in the absolute value, but then we keep it the greater than or equal to the positive 1.6. So again, on one of them you change the symbol and change the sign. On the other one you keep the symbol and keep the sign. Okay, change and change, keep and keep. The stuff in the absolute value is the same on both. Then you solve from there, right? So here you subtract off the 3, you get 8x less than or equal to negative 4.6, and divide out the 8, and I don't know what that's going to end up being. What's 46 divided by 8? Not quite 6. 5 and 3/4, 5.75 maybe? Something like that. Let's double check. I don't have a calculator on. Yes, I do. Here's a calculator. 4.6 divided by 8. How about 0.575? Put the decimal in the wrong spot. That would work. There it is. 0.575. And then the other one here, if I subtract my 3, I get 8x greater than or equal to, what's that, negative 1.4. And then divide that by 8. X is going to be greater than or equal to negative 0.175? No. Yes. 0.175, let me just double check. 14 divided by 8. Yep, that should be right. Okay. So those are my 2 inequalities, and of course you could put those into your intervals. I won't go through all the details of that at this point. I will make a real quick solution set just to finish this off. There it is, very quickly in a solution set. Now, the last thing I wanted to mention is just a general format with a greater than. Okay, and I did that in a previous video with a cloud and kind of made it look all nice. So that's what I want to do here, just to kind of wrap these up. And so if you ever have an absolute value, we'll do the little cloud again, greater than a number, okay, absolute value is greater than a number, then you want to write it into 2 inequalities. One of them has that same stuff from inside the absolute value, but it's going to be less than the negative of that number, or that cloud greater than the positive, okay? So less than the positive gives you everything on the left end, less than the negative gives you everything on the left end, greater than the positive gives you everything on the right end of the number line. Okay, and those are the 2 ends that we're looking for when we're dealing with the greater than, because you're looking for, once again, all numbers whose distance from 0 is greater than that c. So you're looking at stuff on the ends, the negative end, the positive end, okay? There is one weird thing that happens. Again, this c has to be positive for this to work. If the c value is negative to begin with, if you were to have something weird like absolute value of x is greater than -8, well, absolute values are always greater than negative numbers because they're either positive or 0, right? So if you have a negative on the other side with a greater than, because absolute values are always greater than negatives, this is all real numbers as solutions. So you'd have a solution set or interval from negative infinity to infinity on those. Okay, so that's kind of a weird exception. You must have a positive number over here for this rule to work.